Good morning, ladies and gentlemen. I'm so glad to be here. And so thank you for the Translational Medicine Center to give me this opportunity. So my name is Gantsetseg Garmaa. So I'm a second-year PhD student at the Institute of Translational Medicine. My professor is Gabor Kokeni. So here you can see my thesis title. It's the role of microRNAs in renal fibrosis and their molecular pathways. So you can see our team here, also SMS and biostatistician. So now I would like to introduce why we are planning to do this meta-analysis and systematic research and my vision. So personally, I would like to be the big contributor to supporting healthy community that is supported by evidence-based medicine and translation medicine. So in terms of my doctoral degree, and in this career, I would like to investigate the novel diagnostic microRNAs in chronic. Regarding my mission and vision, I set a two specific goal. I will talk about this later in detail. So now, before I jump into the projects, I would like to give you a brief introduction about why we really need to focus on chronic kidney disease and microRNA. So I would call this chronic kidney disease as a CKD. And so I would say it's a silent killer. So regarding your age and races, in the world there is like 700 million people affected by this disease. And so how we are detecting this disease? Actually, the person can lose up to 90% of their kidney function without experiencing any symptoms. So we have a golden standard to diagnose this disease, the biopsy, but it's an invasive method. So how are we going to improve this diagnostic approach? Actually, we need the new diagnostic markers. And so what it could be? Actually, in the last 10 years, microRNAs got an attention. So maybe that could be the diagnostic new tool. So what is the implication of developing new biomarkers in a field? Of course, we're going to be economic benefits. And second, maybe we can decrease the renal replacement therapy in the future. So based on this history and framework, I would like to investigate the microRNA situation in CKD. And so we will conduct two projects for microRNA and CKD. And the first project is the identification of microRNAs related to mammalian chronic kidney disease. So here you can see our team, project students, and fair and biostatistician. So I want to also give you a little bit information about the background. So what is the microRNA and CKD? Actually, microRNAs are more stable molecules than messenger RNAs. And so we can also find this molecule in any kind of biological fluids. So I want to ask your attention on the left side of the screen now. So if you can see the picture, let's say we have a different kind of biological samples, urine and blood, and so we can check these microRNAs using PCR, but in that case we can only see the preselected few microRNAs. But we are not going to use these results in that case. On the other hand, we are trying to focus on profiling studies. It's the next-gen sequencing and microRNA tools. After we get the results from these profiling assays, we're going to get the most dysregulated microRNAs in any type of disease. And so after that, we can also possibility to do gene enrichment analysis, and we can also see target gene and molecular pathways. So based on this framework, we set the hypothesis like maybe the CKD is characterized by dysregulated microRNAs in profiling assays in CKD. So in order to check this hypothesis, we asked the question, what are the most dysregulated microRNAs in mammalian CKD? In that case, we're going to focus on human and animal studies. We collect human and animal data. We also see the peak goals here, and you can also see the specific goal here. In this slide, I also wanted to highlight the clinical implication of this study. First, after we complete this meta-analysis, we're gonna know the candidate microRNAs in human and animal CKD. Using our results, maybe someone who are interested in microRNA field, they can improve the diagnostic approach using these results. And so also we can check the new molecular pathways based on individual microRNAs. So according to protocol, we did a systematic search. You can see a lot of numbers here and logistics and search key. At the first stage, we dealt with the 17,000 articles and we followed the protocol. Now we are dealing with the full text selection and data extraction. So we got around like 70 articles, 60 articles. So it's my second project, but in this project, we're going to focus on diagnostic accuracy of microRNAs in chronic kidney disease in human field. Also the background, what is the diagnostic accuracy of microRNAs nowadays? So we can say now, in this century, we are using serum creatinine, EGFR, and proteinuria as the diagnostic tools. But we can say there is still room for improvements. We need new sensitive diagnostic biomarkers, especially for early diagnostic of CKD. So, as you can see this picture, I also told you like biopsy is the golden standard. But if the risk to doing these techniques outweigh the risk, we can only do these techniques. So, I also want to give some example for microRNA. For example, microRNA 193A has a high sensitivity and specificity for diagnosing focal segmental glomerular sclerosis. So, based on this framework, we set the hypothesis maybe urinary and circulating microRNAs are essential diagnostic marker in CKD. So, we also set the question, what is the diagnostic accuracy of microRNAs in humans diagnosed with chronic kidney disease compared with healthy individuals? We also set the P goals and specific goal here. I also want to emphasize the clinical implication of this study. After we complete this meta-analysis, we know the all published articles diagnostic accuracy of microRNAs. So what is going on there? What is actually the diagnostic accuracy of these molecules? And so we also can highlight the potential one as a non-invasive markers in the future research. So we, according to protocol, we also do the systematic search and deal with the numbers. Now we are completed the Prosper registration for this project number 2. And in this slides, I want to give the brief overview of how we are planning to submit and future plan. And the first project, we were planning to submit the scientific article publication on March. The second one, we were planning to on July. So, and the last, I would like to adopt some Mongolian proverb. It means, in English translation, where there is a will, there is always a way. And thank you for your attention.
Well, my question is that in your first meta-analysis, I mean, you put together animal data with human data, which, I mean, sometimes is worryful. I mean, maybe not here, because if the same microRNA is, I mean, expressed or secreted or whatever in exosomes, that's fine. But this is another thing which have to be actually proved. So, is it, since you have actually a very high number of records and also actually quite high number of reasonable studies which you can include, that wouldn't it be better just to concentrate on human data?
Thank you very much for very picky questions. So it was a question right before we starting this project. But I'm a PhD student in Translation Medicine department, but there is a tons of scientists who are doing the basic and translation medicine and dealing with the mice and rats. So, but there's nobody to summarize this data and see how the animal data and human data can adapt each other's. So, if there is a lot of works, we just wanted to check what is going on with the animal and human. Actually, we're going to do the analysis in separate way. First, we see the animal data and human, and we can make one summarized conclusion based on these results.